And we are live. Welcome, everybody, and thank you for joining us in another network session with CoreCode. For whoever, if you're not familiar with CoreCode, CoreCode is a space for collaboration and continuous learning. We facilitate intensive programming courses and, of course, network sessions. Through our network sessions, we seek to join you so you can connect with people in the tech world and so we can connect with new inspiring ideas. That being said, I am Sofía and I will be facilitating this session along with Fredy. So I'm passing the mic along to him.
Hello, everybody. My name is Fredy and I'm a mechatronics engineer. I can probably say I was a part of the team that built the first water modern satellite, Quetzal-1 or Quetzal-1 in Spanish. So it was a CubeSat, and a CubeSat is a small satellite. It's 10 by 10 by 10 centimeters, it's a cube. And the mission primary objective is to test a multispectral sensor to acquire remote sensing data for natural resource management. So that being said, I introduce you to the coolest part of the night, Jared.
Thank you, Jared. If you can tell us a bit about yourself and the topic you're going to be talking about tonight.
Hey, I'm Jared. Nice to meet you all. I have a slide about myself, but I'm just going to skip it when it gets to my presentation.
Awesome.
I'm an engineer I work on a program called Starlink at SpaceX. I studied computer science and economics in New York at Columbia. After that, I went and I did some, I was a back-end engineer working on automated lab equipment, like robotic biology research equipment. And then I spent a year in the city, in Guatemala City, working at UFM and UVG. And I apologize, but I learned like zero Spanish. It's really embarrassing. But and so I apologize for having to use English. But after that, I came back to the States. When I was in Guatemala, I was looking at internet infrastructure around the country. And then I came back to the US. I spent some time in New York and San Francisco, and now I've been at SpaceX in Seattle for a year. I work on a lot of different things at SpaceX, some of them being like optical profiles and brightness. And I also do network software, flight software, and some consumer research stuff. So I'm really excited to talk to you guys today. I'm going to talk a little bit about principles around how to think about engineering problems and the ways that I have found the most effective people that I've worked with to, I found that the way that they approach problems. So I think that it'll be fun, and I'm excited to meet all of you, and thank you for having me.
Thank you, Jared.
Thank you, Jared. Yeah, I was just gonna mention for all the people who are watching us right now, there's a comment section, probably here or down there, and you can be commenting questions, just comments, and we're gonna try and present them throughout the presentation. And so that being said, I'm gonna pass Jared the mic, and so he can start with his presentation. So thank you, Faye, and thank you, Jared.
Cool. Hey guys. All right, can everyone see? I guess I don't get any audio feedback, so I'm going to assume everyone can see. Please let me know if you can't.
Yes, we can see you.
So I am calling this Thinking Like an Engineer. I don't know, it seems like a nifty title. I hope you like it. Okay, so this is my intro slide, which now is like zero value. But a few things that I want to say are, yeah, I mean, this is most of what I just said as my intro. I want to be clear that I am in no way representing SpaceX in this conversation, so I'm not an affiliate. But I'm also not an expert on this stuff. I think that I've worked with a lot of smart people, and I'm like reasonably intelligent myself, and and so this is just some stuff that like I've learned that I hope will be useful. One second, I'm just gonna try to fix my audio for a second. Is that any better? Ah, cool. Okay, great. All right, so next slide. All right, so basically I'm gonna talk about really 4 or 5 different things. The flow of this, I would say, is not incredible because I wanted to think about the things that are most important and not necessarily connected, but maybe we'll find a thread of logic here together that will tie everything. So I want to talk about why like frameworks in your thinking pattern is important when you're discussing engineering problems and why that matters, and then talk about reducing complexity and also cutting scope in the way that you approach problems. What do you have to do? What's the best way to do it? And then have a little bit of a discussion about layers. So a lot of the times, especially when you're engineering things and you're doing it in code, you're building logical layers, right? You're usually trying to emulate either a thought pattern or a physical interaction, but with a like totally novel logical representation. And so where do you divide things? What becomes its own class? Or where do you break apart functions? Those are the kinds of questions that I think are really interesting. And then have a quick discussion about looking at this with a little section of code. So first, I'm going to talk about why we should care about this. So caring about the framework that you use when you approach new engineering problems is important, because the wrong way to think about like doing engineering work is to say, okay, this is a totally new problem. I'm going to attack it as if it's a new problem from the ground up. And now problem 2 is also a totally new problem, and I get to carry nothing over from problem 1, right? This is incorrect, because you will very quickly start to realize that problems that you solve follow patterns, and having good pattern recognition and being able to, as quickly as possible, figure out, okay, this is I have an example there, a data storage problem, right? I know I'm trying to save the names of people that enter in their information, but this is what that fundamental problem is. I've seen it 100 times. I know the different constraints that I have to pay attention to when thinking about it, and I already know the menu of possible solutions that I could come with. And so pattern recognition is really important, and the way that you approach these different types of patterns that you see are going to determine whether or not, as you do more engineering, you also get better at it, right? And so just to think about data storage as an example here, the moment you realize, oh, I need to take data that I have right now and then also be able to access it into the future, right? And you quickly say, okay, do I need this data to persist from session to session? Because if so, now I want to look at storage, right? I probably want to look at like non-volatile memory. But if it's okay for it to be in memory, now this becomes the constraints flip, and the approach that I would want to take changes. So this is why just building a framework actually makes sense. It's because you will encounter problems very frequently that look very similar. Cool. So now I think the most important thing, and it's something that people that I work with at SpaceX are really, really good at, is keeping things as simple as possible, right? Like Elon says this a lot, and he'll say like, the best part is no part. Like the best thing that you can build is building nothing. Right? Like that is awesome, because no engineer is going to be so good that they are faster at building the thing than someone else would be at not having to do it at all. Right? It's like a pretty simple concept. But when I think about engineering, like sometimes people think about their disciplines as arts. I don't think that engineering is an art at all. It is a means to an end, right? Like engineering is the process that goes from, wow, I have an idea that for something that can accomplish some task, and then building the thing that like does the thing or that accomplishes the task, right? The arrow in between that is engineering. And in my mind, what you want to do is you want to make that arrow as short as possible. You want to get there as quickly as possible. And sometimes people are like purists and they'll talk a lot about clean code and modularity, which are all great principles. But in my mind, they are means to an end. And if the thing that you want to build is not made better, or your goal is not accomplished by leaning on those patterns, then don't do it. Right? Like if the thing that you build does the thing you were trying to do, you have been successful. I do not care like what stack you used. If you used a really fancy stack, but your thing doesn't do the thing, you have failed. Like that's it. Right? And I think that is really helpful to hear, especially when I was like a little bit younger, because I would read like Hacker News and see like, oh, everyone's using like, I don't know, back then, like, I don't know, Angular or Vue or something. Maybe React is just coming up, like, right? Or right now, I feel like I hear it a lot, Rust. Like people are using Rust and you should all switch. Well, Rust is super cool, but it doesn't matter. Like I would feel pressure to use those types of technologies. And what I should have been doing is saying, if I can accomplish my goal, then I have achieved what I was trying to achieve. And that's it. Right. So that's something that I think is really helpful. And like the longer the path to get from idea to do the thing, the longer it's going to take you to do the next thing. Right. So I was saying, okay, like patterns and clean code isn't important, but sometimes the thing that you're trying to do or the goal you're trying to accomplish is not just do thing A, right? Do something that you want to do today, but it's also that you are expecting to want to extend this to do thing B, but you're not sure what thing B is yet, right? And then you'll say, oh, okay, if I expect to extend this, then having it be very modular is going to make, even if it makes the path from right now to thing A a little bit longer, it's going to make thing A to thing B much, much shorter. Does that make sense? I guess I can't get any feedback, so I hope it does. Please write a comment if it does not. So on top of keeping your approach simple, like I just want to give a quick example of this. We were talking about data storage before. Sometimes you are trying to build an app and you have to store data, right? Like it's a super common use case. And there are a lot of, like a million fancy ways that you can store data, right? And so like going for a database first is, I think, generally the wrong approach, because if you're trying to do something super stupid, write it to a file. Like only when you start to feel pain from that approach, from the simplest approach, then bump up your complexity, unless it's going to be really hard to do it after. And we'll talk about how to make this a little bit easier when we talk about abstraction layers. But like, do it the dumb way, as dumb as you can, and still be able to do the thing is, I think, like the biggest principle that I would pull, or that like I try and utilize. So on top of that, cut scope. So I mentioned this before, and it's like, there is no engineer, there is no person so talented that they are going to accomplish something faster than the person that decides that they do not have to do it. Like, the fastest way to finish your task is to realize that it is like not a necessary task. It's the best thing in the world because it does a few really powerful things. Obviously, you're done, right? Easy, sweet. But also, especially when it is an extension of the capabilities or the features that you were going to have to do, like, you also don't have to maintain it, right? Next time you want to build something, you don't have to wrestle with it. Like, having the scope that you cover is not just something that's nice because you don't have to do the work to expand the scope, but in the future, when you will want to do thing B, but you expanded scope because you thought maybe I'll want to do thing C. Now you have to deal with like redirecting that arrow, and it's way harder and way more painful. And so I would say that like the best people that I've ever worked with are not really good at understanding complex ideas. They can, but that's not what's impressive. It's the fact that they can take complex ideas, big complex problems, and turn them into simple, small problems, right? And that is something that not only makes it easier to work with them, but it also means that they accelerate the entire team, because now instead of being the only person that can work on it, they have taken a huge problem and broken it down such that even people that aren't as good as them can be really effective. This is like an incredible skill to have. So I would say that cutting scope is like a huge, huge part of what makes the most effective people that I've worked with successful. Okay, now we're gonna, switching gears a little bit, but talk about when you first hear a problem. This, I think, will be something that I think about a lot when people come up with new ideas, either at work, or I have friends that say, okay, like I want to build a widget that reads your mind or something, right? And mind reading widget is a great app. I have no question, no doubt in my mind that if you could build it, you would make a lot of money, or you could change the world or whatever, right? And but that problem, if you can see, can you see my mouse? Yeah. Oh. Okay. So if you look at this sort of like, this is what an engineering solution breaks down to. It breaks down to a lot of different components, right? And what you want to be able to get good at is see those components before you build it. And not like exactly what it will look like, but you want to say, okay, mind reading widget, I'm not worried about the interface, right? I'm worried about being able to fucking read your mind. Like, I'm not concerned about how the server will communicate with the client. Like, I can already tell you what the hardest part of that problem is going to be. And you want to be able to get really good at this and already say, okay, this is a bunch of different blocks, but which is the most painful part? And then it's two things. One, can you not do this? Like, right? If you can take the most difficult thing, or the part of your overall solution that creates the most risk, where, oh, if I just can't figure out that algorithm, then the whole product doesn't work. If you can just make that not required, that is a really excellent way of cutting scope, right? Bringing it back, yeah. And one thing that I would push you to say is, if I told you you are not allowed to have that feature, like, how would you do that? Right? A really cool example at Starlink is a lot of companies, when we launch satellites, we launch 60 at a time. And there's a big question about how do you put the satellites into space? And a lot of the times people would think, okay, you make like some mechanism that shoots the satellite out one by one, or I don't know, you like drop them one at a time, something like that, right? But regardless, it's a mechanism that you have to build that you don't get back, because it has to be part of your, I guess you could recover it, but you're probably not going to be able to recover it. It'll probably stay space junk, and it increases your cost, and it dramatically increases your complexity. Instead, we just throw them out into space and just spin them a little. Right? And this is a really good example of, if you had to not do this, like if you were not allowed to build this mechanism, how would you accomplish this goal? And are able to cut a ton of complexity out of the system for that reason. Right? So that is something that I would challenge you to do. I would say as quickly as possible, practice figuring out the hardest part of a problem. And then also, if you still want to go and build it, see, can I get from idea to do the thing without having to create this hard algorithm? And I like this comic on the side, which is talking about the difference between a really hard and a really easy problem. It says, when a user takes a photo, the app should check whether they're in a national park. say, oh, easy. Like I can do a GIS lookup and check whether the photo is of a bird and say, oh, I'll need a whole research team for that. Right? And that is a good example of very quickly seeing those two problems and being able to quickly identify, I can see what part of that diagram is going to be the really nasty part. Cool. So now I want to talk about code divisions a little bit. So you're creating abstraction layers all the time when you're building things, right? Basically, either you are a lot of the times trying to put logic into code or put like a physical system or a physical interaction into code. Right? And regardless, you're building logical layers out of things that are sort of abstract, and you are going to, like, the bread and butter of software and computer science is abstraction. And so the question of where do you break up, like where do you put sort of the joints, or where do you place the layers of abstraction, I think is something that I find really interesting and also tricky. This is my own opinion, but like I have found that the best way to do this is to place it along sort of the natural degrees of freedom of your problem. And it doesn't mean that every degree of freedom of your problem has a breakpoint or a joint, you could think of it as, but when you place them, it's good if that's how they are placed. Right? And so we can think about this as, which we'll talk about in a second. First of all, when I say degree of freedom of a problem, if we think about our data storage example before, when you are interacting with the user and then you go to store their data, you can store data in a lot of different ways, right? This is sort of a degree of freedom, what I'm talking about, where you could take that data and then store it in a series of different ways. So this is a really good and clean place to create a layer of abstraction where instead of like writing to a file right there, what you can do is you can call out to a function that says write data, and you don't have to care about how it does it. Because then what you can do is you can switch that out to slot in your database when it starts to get really painful that you're just writing like a JSON file. And that is an example of where you would want to lay those layers of abstraction. So I have an example here, which is, I'm not sure if everyone's familiar with Python or if anyone is, but basically, let's imagine that we are like trying to make coffee, right? And we have one main function here, right? And we're importing body, which is like a human body. Your body is kind of a jokey example. But what you want to do is you want to say, okay, I have to go get the coffee and then grind it and then heat up some water and then like brew it and pour it out, right? And so if you are not laying out your abstractions, if you don't do this, you can end up with something sort of like this example, where you get the cabinet location and then you move your feet one by one to the next step, checking your brain for where the next foot should move. And then you find it in the cabinet and use your eyes. And this is like a good anti-pattern for how, by not creating clean divisions, if you wanted to now go and get grapes to make wine, which is a weird example to use, but you would, it is not super easy to utilize a lot of the functionality that you already have. Right? And so if we look at another sort of way to do this, I know this is a little bit harder to see, but doing things like get beans, get water, grind beans, because these are sort of natural layers of where the problem divides, right? You could get beans, but maybe you have ground beans already, right? You buy ground coffee, or maybe you have instant coffee, and so you don't even need to use a coffee machine. These are all like a demonstration of, by dividing your problem, by creating your abstraction layers well, you can extend your code in a much simpler way. And a lot of the times when I am really stuck on something, I will think about like, how does this problem actually divide? What is the most natural way to structure this in my head? When I think about a slightly different problem, where, along what lines does it usually change? And I have found that is, I've been most successful when thinking about problems. Like, what are the fundamental properties of this problem? And that is the best way to design, in my experience. So that's most of what I have. I'm open for questions. We can talk about this a little bit more if you guys are interested in any particular part, but I wanted to give us some time to chat. And so, yeah, here we are.
Thank you, Jared. It was an amazing presentation. I just want to thank you for your time and just give a little wrap up of what you said, and say one of the things that helped me, it was like, do more engineering so you become better at it. And I think this applies for everybody, not for engineers, because engineering is solving problems, and I'm pretty sure that we all have problems in our everyday life. So
that's a good point.
This really motivates us to solve our own problems and to do it, like, learn from them so we can become better at it, right? And also that you say that do it the dumb way and do the thing. That's the way, like a baby step, you start learning. And that's a lot of funny examples, like when we learn like electrical engineering, and not everybody know like how fascinating it is to bright up a LED and what it means. That LED blinking, and also a hello world, like the whole meaning of you seeing something being printed on your screen. That's that taking small achievements. It's what you get for getting better at a discipline. Abstraction, divide your problems, and that satisfaction of those small achievements will make you getting better at what you do. So,
Awesome. Thank you for the wrap up. I'm just gonna read some comments from the audience, and there's a question also. Maybe after that we can continue. There's one from Samantha Montepeque. She says, "Thank you for the examples. They really helped me understand." So yes. And we have also Gustavo Ibarra. He says, "Thanks for the valuable content," and he also has a question. His question is, how do you apply code divisions at Starlink? Any examples?
Yeah, a ton of examples. Let me, I'm trying to think about what I can talk about. Let me use an example of a past company, just because we have like a ton of regulation around our technology. But it is very similar, the way that we think about things. So like when I worked at a company called Opentrons, we were building like robotic, like automated liquid handling machinery, right? And so you could think about it where you could have different like syringes that would suck up different amounts of liquid, and you could have a different location where things could be placed on the floor, right? And these were all natural areas where your problem started to divide, right? You could have a different amount of liquid that each container could hold, and so you would very naturally create these divisions about, okay, in this exact scenario, this is how this would work. But let's say it changes slightly, or there's a slightly different use case, or if I'm trying to accomplish a different kind of goal, would I want this part of my code, but not this other part, right? And so that's a really natural place where you would probably want to split. There's like a mantra or something that like functions should do a single thing, and this is something that helps guide similarly. That like if you are accomplishing a single task, it should be its own function, because that also allows you to avoid repeating yourself, right? Which is another, like, I don't know, code mantra, which is like dry, don't repeat yourself, which is a big, super useful thing to remember. And so you can imagine that, like, if you have different satellites that potentially have different configurations or states, you would really naturally want to be able to divide there such that you can adapt to the different, like, state of a different satellite. You could imagine that satellites can be in different locations, but you can have sort of a layer of abstraction between, like, the different pieces of hardware in the network, right? These are all supernatural layers where you would create these divisions.
Awesome, thank you. I'm gonna read a comment from Samantha. She says, I'm not an engineer or have to do with any of that, but I think these principles can apply to many parts of life, especially the simplifying part. And another comment that's similar would be from Cristobal Samayoa. He says, the complex mentality seems to haunt regular business. Complex equals expensive and easy equals cheap. So wrong. I don't know if you want to comment on that.
Yeah, no, I got two comments. One,
okay.
I think that Samantha, it's very nice to meet you. I don't know you, but I think that a lot of the times people think of engineering as, like, either you are an engineer or you're not. Like, if you are making something and you are saying, I really want to accomplish this thing, and then you try and think hard about the way that you can do it, and then you make it happen, that feels a lot like engineering to me, right? And so I think a lot of the times I've met people that are sort of self-taught, and it's just because they're saying, I'm not an engineer, but I just learned how to build this thing. And then one day they wake up and they're like, oh, wait, like, am I an engineer now? Like, that's cool. And I think that, like, when people call themselves, like, I'm not an engineer, like, I don't believe you. I think that you totally can be. I don't think it's, like, a binary thing. I also, like, totally agree on the complex versus easy mentality. I think sometimes people will say, oh, this is, like, the right way to do it. This is the way that everybody else is doing it. And I understand thinking about precedent and other comparisons, but, like, people are really stupid, right? And lazy in general. Like, and just, like, I am too, right? Like, and so just because somebody's doing that way, it doesn't mean that it's the right way to do it. And I think that challenging yourself to being like, what is the absolute dumbest way that I could do this? Like, how would, like, a child approach this problem is a really cool way to cut complexity. Right? So I agree with you. I think it's, like, it's stupid to just think of, like, what's the complex thing that I can trust? It's a super risk-averse way to approach problems.
Nice. And we have two more questions. Are there, like, this is Jimena, are there, like, specific ways to practice how to simplify complex things and learn to have kind of, like, a simple or basic thinking?
It's a good question. Yeah, I think that there are a few parts to this. One is, if you want to take problems piece by piece, you need to learn how to break them down. And this is something that I actually think having to build something is awesome, because you can't skip any of the details. Right? Like, if you make a PowerPoint like mine, you can sort of say, like, oh, I don't know how to do this, so I'm just gonna, like, put 3 bullet points and then go to the next slide. And you can't do that if you're trying to, like, build a bicycle, right? Or, like, and so it forces you to learn how to break down problems really well. And once you can identify the components of a problem, you can say, okay, I need to accomplish this goal. This component works, but it's not the only one. Is there a simpler way to do it? Like, is there a stupider thing that I can do? And I know that that's not, like, really good at answering your question, but that would be my first thought. I also think that like if you have a base assumption at a problem, unless the limit that you are up against is physics, you are not thinking about it right. Right? It's okay to say, wow, like we are limited by the fact that this thing does not exist, and that's fine. But if it's physically possible, you at least want to have thought about it, have looked it up, and been like, okay, we have to wait 100 years, and then go to the other thing.
Awesome. We have more questions. I don't know if Fredy wants to comment on them too, or no.
Just to comment this question of how to practice, how to specifically simplify problems. I agree with breaking down the problems. It's one of the best strategies to learn or to practice how to simplify, because even basic things can be simplified if you take the time to do it. And simplifying the most basic things is one of the best exercises for get better at this, I will say.
Awesome. We're gonna jump to the next question. We have Otto Castillo. He says, do you ever have analysis paralysis? Any mechanisms besides divide the problem into smaller ones?
Yes. This is something that I think about a lot. And usually the answer is just like, make a fucking decision. Like, standing still is almost always worse than moving quickly, because you will find out that you're wrong generally a lot faster if you make a decision, right? And so obviously it's very different, because some decisions are like, this is a $10 million decision. Like, if we realize we're wrong, it's going to hurt a lot, right? But you want to think about your risk posture. So like, okay, if I make this decision, what's the likelihood that I'm wrong? And if I am, how quickly will I figure it out? And how painful will it be? And when you think about things like that, usually the really cheap solution that you find out is incorrect very fast is almost always the right thing to do. Right? Like go to like, I don't know, go to like your kitchen, get some duct tape and like tape it together before you go and like buy screws or anything. But if it's gonna like, if you're trying to build something that's gonna keep your child safe, maybe you should start with screws. Right? But I think that it's very common that you can analyze things to death, and A, your analysis is wrong, and B, it would have been quicker to just buy something and break it and figure it out, because like your time also has a lot of value, right? And so I will get most frustrated at work, or like in general, not when we're wrong, but when we are like just going and hemming and hawing and going back and forth, and like we're like too scared to actually make a call.
That's like the idea of prototyping: fail faster and cheaper.
It's a much better way to put it. Yeah.
Thank you, Fredy. We have the next question. Gustavo Ibarra is asking, do you use any open source hardware?
Gus, do you mean me specifically or SpaceX?
I think you could answer to both, since we don't have all the information. Yeah, if you can. I don't know if it's like legal.
Yeah, I'll answer personally, just because talking about any technology that we use is like gets a little shifty. Just because we're under a regulatory, I don't know, protocol, or like we're regulated by ITAR, because we build like, they're not missiles, but like they're kind of close, right? And so the regulation is really strict. And so like talking about our technology is usually something we try to stay away from. But I really like open source like software and hardware in general. I have like worked with a few specific open source things. I think that the biggest one is like smoothie boards for motor controllers, something that I worked with, and I really like it. I found the documentation pretty cool, and it was super useful. Yeah, I wish that open source hardware was a little bit bigger. Like it was a bigger market, but I also think that it's really sad how few people are interested in it or are not scared of it is really the thing. I feel like for a lot of hardware, once you start to figure it out, once you like solve your first few problems, you start to realize that, okay, this is doable, but it's very intimidating.
Yeah, I got curious. I don't know if Fredy, like in Quetzal-1, I don't know how like legal it is to ask this again, but you feel comfortable with whatever answer. Do you guys use any open source hardware?
Yes, and I think it's one of the most known open source hardware in the world. It's called Arduino. So the satellite has Arduino microprocessors for controlling things, and that's the thing. We don't want to get the most complex solution or the most elegant solution for the thing. Want to make it fast, want to make it cheap and functional. So open source hardware.
Awesome. Thank you, Fredy. Let's jump to the next one. There is the Sebas Ibarwen. He's asking, what differences have you seen between building solutions in hardware versus software?
A lot. I'd say that, this is a big question. Generally, I think that software can be, so first, if there's a way to do it in software and there's a way to do it in hardware, like do it in software every single time, right? Like never do something, because like the physical world sucks, right? It's so hard, it changes so much. Like we've spent a lot of time like beating up electricity to make it pretty predictable in computers. And I would always trust that versus like me exploring nature. And like, and so I would definitely always say that. I mean, like the capital expense is definitely going to be higher. Your testing fixtures are going to be a lot more difficult. You usually need more people to do it. Like the disciplines that you will have to deal with can be much larger, right? You could have to do mechanical engineering. You could do like materials. You might have to be thinking about E&M. Like there are a lot of different disciplines that could be involved. I doubt that there's documentation also, especially if you have to like, design something from scratch. Yeah, that is but software can get super hairy and annoying, and you can want to pull your hair out and you can't touch it or see it or like physically experience it. So it can be a little bit harder to debug, but like easy trade. Still, I trade that for in exchange for all the hardware issues any day.
Yes, like in hardware, you can see the thing if it's broke or something. In software, you cannot, but it's a lot cheaper, and you can be a little bit less afraid to try new things. Like let's try putting this in software, and let's see what happens. When in hardware, it's a whole different thing. If you do that, you can break the whole thing, and you're done. Your money is done. So that's a trade-off. Everything is a trade-off. But I really agree in what you say, Jared, that if you can do something in software, always do it in software.
Also, something to remember is that when you do it in software, you have to do it only once.
Yes.
Like, you don't have to do it once for every single unit that you want to produce.
What do you mean by doing it just once? I didn't quite get it.
Like, let's say I realize that I'm manufacturing cars or something, right? And like the brakes have an issue, and I could either solve it by like changing the brake pads or changing the software. I'll have to change every single brake pad, but I only have to like download that software or like update the software on all the vehicles and write it one time.
Got it. Jump into the next one. Diego Soler is asking, that's more about your experience in Guate. How was your experience at Guatemala? Do you think we tend to stick to that complex mentality?
I had like an unbelievable time in Guatemala. I had such an incredible time and met so many really amazing people. I'd find it very difficult to generalize about the whole country. Like, yeah, there were definitely people that had like mentalities that increased complexity, but I mean, there were also a ton of brilliant people that like helped me realize that I was doing things in a really stupid way sometimes, and right, would sit down with me and be like, dude, like that is a really hard problem that you do not have to solve. Like you do not have to worry about that. Like, oh yeah, okay, good point. Thanks. And one thing that I actually wanted to talk about is that occasionally I like made friends in Guate that like felt as though because they were from a country that they didn't feel like was as like major or dominant, the doors that they could walk through were more limited. And I just like want to be really clear that I don't think that this is the case. Like I met an incredible swath of talented people while I was there, and have also met a lot of other talented people, and like they're in the same group in my head, right? Like, so if you feel that way at all, I would just challenge that, because that's one nice thing about engineering specifically, but I would challenge it in general. But engineering, it's really easy to prove that you can do something, right? Because you can physically do it. Like, and that is a really nice way, because you can demonstrate that like I'm right there with everyone else that's building, as a good example, like other satellites, right? Because like Quetzal-1 is in fucking space. Like that's so cool, right? It's like launched out of the International Space Station, like the coolest thing in the world. It's really hard to be like, oh yeah, but it's from a different country, or it's not like a super major thing. Like, nah, it's in space. There's no way to get around that, right? And I think that like that is something that is really important and easy to forget. So that was super long-winded. I'm sorry. I like really had an incredible like time in Guatemala, and I think about it a lot, and it really has like shaped me as a person in a lot of ways. Yeah, and so I couldn't make a generalization. I'd say that in general, like people in Guatemala were at the exact same level as people that I've met anywhere else. Like I don't think that there was a difference.
Awesome, thank you. I loved the response, because it does happen here in Guate that lots of people, or lots of us, including ourselves, we get like, oh no, yeah, we're so complex. We're never looking at the simple way of things. And we say that, and I think we sometimes say it so much that we get to believe it. So I think the word you used, the challenging that mindset, is super important to remember, right? What are the things we're believing about ourselves? What are the things we're actually capable of doing? And I love the word challenge, so I wanted to highlight it.
I do want to say though, I did deal with the government like once or twice.
Oh yeah.
That was not easy. That was definitely
yes. I'm just gonna say yes. Thank you for that. There are a lot of questions, and they're super interesting. I'm gonna keep reading them. There's another one from Mr. Otto Castillo. He's asking, what has been the biggest problem you have faced in your career?
Good question.
Yeah, a deep one.
I would. This is a really good question, and not one that I would prepare to answer for. I could pick a technical problem, but in general, I think in your career, the technical problems are not the hard ones. Like because you get really quick feedback, right? You know that you're wrong very quickly. The scary problems are the one where you make the decision, they put you on two very different paths, and you only find out that you're wrong like 10 years later. Right? And so maybe one of the trickiest decisions I had to make when I was in college, I was working at a bank and I was doing non-technical work. I was like an analyst at JP Morgan. And this was like a job that my parents thought was really cool and was fine. And I took a pretty big risk by being like, I don't want to work here. I'm going to go and like do another year of school and do computer science. And I didn't know if that was the right decision at all. Like, I feel like now it was personally, but I think that was like a really tricky one to try and work through.
Thank you for sharing. And we're glad, I mean, I think we're glad you took that decision in the end, right?
Yeah.
It's been fun. Gustavo Ibarra is asking, how do you debug a satellite that's already on space? That could be a question for both of you because you guys share that area.
Fredy, you start.
All right. So because obviously the satellite's already in space, you cannot touch it, you cannot see it, but you receive some communication from it. And there's a beacon when you can receive a different amount of data, like the whole of the batteries, the status of some electrical components, and for us that's the way to see how the satellite's going in space. We can see if something just burned because of something and start making hypotheses and trying different settings on the satellite to see if that fixed the problem. And that's the way we debug a satellite from here. But we are like very limited on that. But you have to get creative to solve those problems. But yeah, it's basically receiving information from the satellite, from the debug, and this also makes sense when a year before you're thinking that you will have to debug the satellite, and you are like thinking, what will be useful to have as an information when I will have to debug something that I cannot touch or change.
Yeah, I mean, I'm basically just going to repeat what Fredy said. Like, super hard thing to do, and it's a lot of hypothesis construction, testing. Like, we call that information that's downlinked from the satellite telemetry. And so you're looking at telemetry being like, okay, right, you have the data here, but you don't have it here. Like, there's nothing in between these things. What the hell is going on? Right? You get into those situations a lot, and it's a pretty interesting technical constraint that I had never seen before working on something that was in space.
Yeah, because it's not like you have a car and another car just stopped working because of the same thing. And you have a satellite with an experiment inside of it. So you actually don't have a lot of documentation of what is going on. So you have to start making hypotheses on what is going on in space. That space it's weird.
Yeah, right? Like, and things that happen in space sometimes don't happen anywhere else on Earth.
Yes.
The way that light works in space is totally different, right? Like, thermal properties, the thermal cycling in space is really nasty. Like, you have 11-year solar cycles. So, like, the density of the atmosphere will change on 11-year timescales. Like, space is just awful. It's super
I'm just curious, like, when you develop like software for space, like, is it technically different, or or is the only difference the variables? Like,
it depends what you're doing.
mhm.
So you can imagine that like something in space can be far enough away that you will have to correct for for relativity, where time works differently on the satellite than it does on Earth, right? And like that is not a component in your software that you need if you have something on Earth. That is totally something different. The same thing goes for like correcting for soft errors, which are errors where like when radiation hits your board, you can like flip a bit, which can like totally fuck your shit up, right? Like, totally mess you up. And so you have challenges in space that are not just quantitatively different, but are qualitatively different types of challenges. But what you try to do, like the abstraction layers that I was talking about before, is you try and put all those in a bucket where all your normal software doesn't have to think about it because it's corrected sort of at a lower layer.
I think also one of the most common difference in space software is that you have redundancy that you like. It's not really common to see on Earth software because you don't have the chance to check it or fix it. So you make twice or softwares or components. So you make sure that if one part of the software just doesn't work, there's the other part that will save the failing one.
Nice, interesting. There's a question right here for Fredy specifically. Fredy, what were some of the challenges to make the Quetzal-1?
I'll say the knowledge, because we were all students, and I think 25 years old was the average year of the team. So that was a really, really big challenge because we really didn't know what a satellite was, and we were building one. So knowledge and asking, and you have to make sure that, or like be honest with yourself and say, I don't know this. I will have to ask for this or put a lot of time in this so I can solve this problem. So I think one of the biggest problems or challenge in making the Quetzal-1 was the knowledge. We don't have previous knowledge, and basically that. Taking the problem, don't be afraid of the problem. Like it will 5 years ago, a lot of people was like, oh, a satellite, we can do that. It's just too big for us. But there was a small team there in the university that say, yes, maybe we can, and start by small steps. Start like imagine how it will be, and it's orbiting the Earth right now. So how cool is that?
It's awesome.
Yeah, I'm a bit speechless right now. It's truly inspiring to hear that, really. So thank you for taking those steps.
And I think that's one of the achievements for us. Not just like making the satellite and putting it in orbit, but also inspiring people of Guatemala to do that kind of things, to dream and to like really think that you can do these things, even if you are not in SpaceX. If you are in Guatemala, you can also do satellites, and that's the thing. We all can do huge things if we invest time on ourselves, learning and keeping the things up. I think it's just.
Thank you. Just thank you for that. I think a lot of us need to hear that. So thank you so much for taking the steps and for getting us to space. So thank you I'm gonna continue with the last questions. I think we're gonna give just 3 more because it's almost time. So let's run a bit. Isaias Buga is asking another deep question, which is, Jared, what advice would you give to your younger self?
Depends how young. But I would say that I feel like I was like, I think I spent a lot of time pretty nervous about what direction I was going in. And it feels like the right thing to do in my mind is sort of just figure out something that you think is fun but really hard. Like something that when it's really hard is still fun. And also make sure that that's the kind of thing that like puts you in a direction where you can like be okay. I'm lucky that my interests align well with being able to feed myself, and that is a really good thing when that happens. And if that's the case, then just like do that, because you're going to be better at that than you probably will be at most other things, right? And like just relax and like take a lot of risk and do things that are interesting, are productive, and that are hard and that you like. And like if you got all that, you're going to be fine. And I think that it would have been really useful and lowered my blood pressure a lot if I had known that earlier on.
I have a question, like a question from a younger person, younger self. Like, why would you choose to do things that are hard? Like, it's so easy to choose things that are easy and fun. Why would I choose something that's actually hard?
I feel like there is something, not to get like super deep, but I think that there is something like supremely human in overcoming, in like the satisfaction you get when you overcome a challenge, right? Like when you have a moment where you're like, I cannot do this, and then you have a moment where you realize that you did. I think it is just like something that's sort of more special than almost any other feeling. And being able to look back and be like, wow, I like made something. I feel stupid having Fredy on the call and having me talk about this. like Fredy should totally be the one saying this, but like
I'm just taking notes of you.
Yeah. I mean, like, Fredy, what was the feeling like when you got the first communication down from the Quetzal-1?
Well, we cried. we cried because I mean it's like every single little step. Like the first when the dragon went up, first huge moment. The dragon didn't explode. The satellite arrived safe. So okay, we are closer. And then when the satellite was deployed from the International Space Station, we were in a Zoom conference with all the team, just watching and celebrating. Like, whoa, we are closer. And then it was a matter of time, like 30 minutes, and we didn't receive the signal. 1 hour, we didn't receive a signal. And there was like a few minutes there, and we received like kind of a signal in I think it was Germany or something, but it wasn't really decode right. So we were starting thinking like, oh, the deploy system of I forgot the word. The communication system is wrong. Something just burned or something. But when we received the first that was good, it was like that feeling is. I don't have words for that feeling. It's undescribable. It's just like a peace and calm, and also an excitement of you done something that you thought it was impossible. Like Jared said, it's a speech. I don't know. I don't know how to describe it. You have to feel it.
Yeah, and like I don't think you have to like send a satellite to space to get that feeling, right? Like it's crazy that that's how you got it, which is so cool.
Yeah.
But like you can get that like just doing anything that you think you can.
Absolutely.
Yeah, that's what I was thinking. I haven't launched anything to space. I'm the only one in this screen who hasn't, but I can, yeah, exactly. Like I can relate with the feeling of doing things that are hard, because I'm guessing that when things go wrong and you're doing something hard, it may hurt more. But then the pleasure you get when you get it right after all the hard work you put into it, it's really just worth it, right? It's the purpose in it. You're launching a satellite, or you're launching a business, or you're starting a book, you're starting a post, you're starting an article. It's just anything that's hard for you after the work. I think we've all experienced it someday in our lives. Maybe even just making someone smile. If it took effort, the pleasure ends up being so great. So
Yeah,
thank
something
you
as
all.
simple as a homework, you can trick your brain to take that that good feeling of solving problems or getting off something hard.
Yeah, that's super powerful. Thank you both for making me cry. I'm gonna go with the last two questions. I would love to read more, but I think we're in time already. Javier Ogarrio is asking, how do you manage software product deliveries at SpaceX? For example, if you are to deliver a new functionality, but it's taking longer than expected, do you move dates, remove features? Yeah, I think it has a lot to do with the management process.
Yeah, I think that like we do our best to just do the right thing given the context. And I know that's sort of a BS answer, but like I think that having a strict rule in either direction is always sometimes wrong, right? And so it's basically you make a trade where you say, okay, we can deliver everything, we can deliver on time, or we can deliver like have it be good or expand the team, right? Like it's basically you usually have these different knobs to play with, and the question is, can you still get like the minimum functionality by descoping the features? It's always the best thing to do, right? Like I would start with saying like, can we just not do this? Because that is great. And then it becomes a question of like, are we going to slip on schedule? And if so, let's figure that out as quickly as we can and tell everyone, right? And like broadcast it out to the world, because they're not trying to make us like be bad or like get us in trouble. We're just trying to build something together. And when you're aligned in that way, you're not scared of it being broken. You're like, this is the situation. It's broken. Let's move forward. Like, let's fix it, right? And I've been at other companies where they're like, no, this feature has to be in. And it's like, dude, why? Like, it doesn't make sense. Like, this is not important, right? And so I think that that's something that like we try to do. And if people are like, this is impossible, or this has to be X, Y, or Z, usually you want to challenge the assumptions, but also move like as quickly as possible.
Awesome. Maybe also Fredy could answer that question, like in the management terms of Quetzal-1. If you have any management system.
Well, yes.
Similar.
It wasn't that. It was a little bit messy in a way that we didn't have the knowledge of how to do that, and we just trying to complete some tasks. But we were a really big team at a time, like 100 people working on it, and some people working in really small tasks, and some like just taking data from batteries in an oven, and other people working in the onboard computer software. And yeah, working with a lot of people is also a complex problem of people solving complex problem, I'll say. So I don't know, it was a really rough way to do it, but we just have a big drive and managing all this software there, like a backup or something. Yeah, it wasn't the most beautiful way to do it.
Did you end up delivering all the features that you planned to in the beginning?
In the beginning, actually, no.
Or when you started working on it, whichever you know, I don't know.
No. It was time was a really big constraint for us. I think if we had more time, we can do better things with the satellite. But yeah, maybe because of the time. But it's the biggest constraint in that kind of projects.
Yeah.
I think.
I mean, you would have either slipped massively on schedule or massively on features, right? I'm surprised that it wasn't both. Like, it's really hard to do anything like that on time. Yeah, that's interesting.
Awesome. And last question. What are good and accessible resources for learning about space, physics, mechanics? Is this knowledge even reachable?
Sure.
I think you're going to be better at answering this than I am. So
sure. You're now in YouTube. So when this conference finish, you can just search for something like that in the search engine, and it will be a whole lot of different funny channels that are also very professional. There's a lot of professional people making like funny content that is also educational content that you can learn from the easy way. There's also like MIT classes online on YouTube, like rocket science classes recorded of MIT on YouTube. You can take the first steps, like watching this educational content that is very graphic and very interesting. Is really easy to digest, I say, and you can learn what you like, because you don't know what you like if you don't know what you don't know. And yeah, there's a lot of free information on the internet. And I really like subscribing to a lot of science channels on YouTube, and you learn a lot of that, and you don't even feel like you're learning in a classroom or something.
I also think a cool way to do this is to try to build something and to have it be something that like you do not know how to build, right? Where you're like, I'm gonna have to learn like how to write code for Arduino, right? And something pretty basic, but like something where I'm definitely gonna have to look it up and I'm going to have to watch videos. But when I watch them or when I go through a textbook, I'm not like, okay, let's start at the intro of this textbook. Like, where the writer's like, back in the 1800s, I like learned about mechanics. It's like, okay, right? Like, it's really cool to have a project where you're looking at the appendix or something and you're saying, okay, I'm trying to figure out how beams are loaded, or like the bending moment on a beam. And you're like, I just have to make sure that I don't destroy my house when I like install a swing. Right? It's a really good way to start to learn that type of stuff. Because it's like, it's much more directed, and you have a goal in mind that's a lot more concrete.
Yeah,
Yes.
a word that came into my mind is like backward design, but like backward learning. Like start with what you want to build and then ask the questions. That's what got into my mind. And I also think it would be cool if you guys could like send me some links that I could put down there. If you have any favorite, like you mentioned, Fredy, you have a favorite YouTube channel, we can add it there. And I think that would be awesome. So now we're going to have to close this awesome conversation. But thank you guys. It's truly an honor to be sharing a screen with you two. At CoreCode, we truly believe in these dreams, right? In this keep continuous learning, and that we can get to the stars, whatever that may mean for each one of us, right? We all set our own stars. So I don't know if you guys have a final message to share, so we can end this amazing conversation.
No, thank you so much for having me, Sofía. I really appreciate it. It was also really nice to see you, and I met Sofía at UFM during my time in Guatemala, and like it's really cool to see that. I'm just really excited at how awesome CoreCode looks and how like much it's growing and how fast you guys are accelerating. So I'm really excited to be a part of it and to be here today. Thank you.
Thank you, Jared, and thank you, Fredy. I don't know if you have anything else to share.
Yes, I would just want to thank Jared for your time and for your thoughts. I really learn a lot from what you say. You're an inspiration. And nice to meet you, Jared. And thank you all people who are watching us right now. Never stop learning. And don't be afraid of solving problems.
Awesome. And if you guys want to, like you guys also, but anyone who's watching, if you want to join more of the conversations we're going to be having at CoreCode, you can see the link below. You can like say, oh, I want to receive emails with this awesome event. So it's an honor, and thank you all. Keep learning and keep dreaming. We're going to